So let's get started with this, and we'll kind of move a little bit faster. So as I started to say, AGF Manufacturing is basically a family-run corporation that's been around for 30 years. We specialize in manufacturing products specifically for the fire sprinkler industry. Typically, there are ancillary products like the valves and other devices that are used to control sprinkler systems. We're probably most familiar with a product line of ours called Test and Drain, which are valves that are found in the stairwells of most buildings. But today we're going to be talking about dry systems because, well, it's winter out, so why not? So with regards to dry systems, so basically the code regulations for dry systems are anywhere that you have in an area of a building or a structure that can't be maintained at or above 40 degrees, you need to use something called a dry or pre-action system. A pre-action system is basically a dry system. And as part of that, all those systems need to have auxiliary drains so that you can potentially eliminate the moisture from those systems. Now, dry systems can be very large, protecting an entire structure like a parking garage or warehouse or a manufacturing facility, or they can also be smaller subsystems protecting areas like one level of parking under a store, office, or multifamily residential complex. They can be used in hospitals, hotels, and in senior care facilities covering entryways. Ambulance bays, loading docks are also common locations for them, as well as places like garden stores or garden centers in home centers, and even outdoor dining areas in restaurants. Even places like the garden centers and the outdoor areas of the dining that aren't actually used in the winter, but they still need to have those protections. I'm going to concentrate today. I mean, dry systems are a pretty broad topic to cover in just a 25-minute period, so I'm going to concentrate on the part of the system that sometimes creates the most issues for building owners and managers, the auxiliary drains. These are also sometimes called drum drips for those. They just have a lot of different terms. And if you look at this slide on the left-hand side, that's pretty much what a typical drum drip looks like. So as the code would say, where the capacity of an isolated trap section is over 5 gallons, the drum drip is basically comprised of these components. If it's under 5 gallons, basically you can just put a valve there. The goal, of course, with a dry system is to get any water that might be in it out of it. So that's your basic drum drip from the standpoint of NFPA. This is kind of more like what one looks like in the field. It's just an assembly of parts, and the way it works is in order to be able to empty it without exhausting the air out of the system is you need to close the valve at the top, open the valve at the bottom to drain out any accumulated moisture, then close the valve at the bottom to reopen the valve at the top. Obviously, a dry valve is what starts at the beginning of a dry system, and it's holding the water at bay, and then the system is filled with compressed air. And if you were to just open both of these valves at the same time, the dry valve would assume that that was a sprinkler head activation and would release the water. So that's why you have this sort of isolated chamber. This is what you typically find out in the field. Sometimes they're painted to try and blend in, which is not necessarily a good idea. The ones that are shown here in the pictures, you can see they're sometimes different sizes, and that's kind of a misnomer, and I'll talk about that in a bit. You can see the one on the right-hand side has a number on it, 16, which also relates to some other issues that we'll talk about later. But as an example, these things are supposed to have signs on them. The one on the right, you can see there's a chain hanging there, but there's no sign, and both of these have no handles on them, and that nobody knows what these are, so they're sometimes difficult to identify. Here's a couple others that we've seen out in the field. The one on the right, it's kind of behind a ballard, makes it almost impossible to get at the valves to drain that, but it also makes it kind of out of sight, out of mind there. And the one on the left, that picture is a little deceptive in that that's about 15 feet in the air, which just makes it very difficult to get at. Here's examples of drum drips where people have tried to put locking out devices. Obviously, they were in a public area, which were prone to being tampered with. They're also trying to insulate them, and this kind of gives you a false sense of security as to both potential freezes and breaks and also tamper with. Most people aren't aware of the kind of the process, and we did a lot of testing on how drum drips break, and unfortunately, it doesn't take a lot of moisture. Some people think that based on the fact that this entire drum, which is over a foot long, can be filled, and then they're not going to have a problem. The reality is you can get a drum drip to break with less than 2 ounces of water. So what will happen is condensation will build up in the drum drip. It'll start to accumulate in the bottom of it. And then what will happen is you'll maybe get a cold cycle. Now, if there's enough room in the drum drip for that, what will happen is as that water freezes, it expands. So as it would expand, if there's enough room for it to expand, you may not end up with a problem. But what will typically happen is that the next day, you'll have a partial warm-up, and you'll start to get a pool of water that will collect under this chunk of ice floating in the pool of water. The water takes up less room, so the ice drops in the unit. And then what will happen is the next day, or that night when it gets cold again, the ice will grab a hold of the sides of the pipe before all the water has frozen, and as that water starts to transfer from a liquid into a solid state, it will try and expand, but now it's trapped between the ice block and the valve. So that's what causes these things to break. And as I said, in testing, we've been able to get them to break with less than 2 ounces of water. What happens then is you'll typically have a breakout at the valve or the threads or the fitting, and then as soon as the ice plug melts, it will release it out the water, and that will end up tripping the drive valve, and now you'll fill the system with water, and of course you'll have water shooting out of this drum drip all over wherever it is located until you get it serviced. This is the best picture I've ever been able to take of a broken drum drip, because what we're looking at there is that's actually a ribbon of ice coming out of the bottom of the valve. Ice can be a very destructive medium, as the people, unfortunately, in the Titanic discovered. That's actually a ribbon of ice. That valve has been fractured. There was nothing wrong. I mean, it was a good quality valve. I blanked out the name on it because of the fact that it wasn't certainly not the manufacturer's fault. And basically that little ribbon of ice has pushed and cracked that, fractured the body of that valve and separated those two from each other. So now what will happen in this parking garage, or what did happen in this parking garage, would be that as you got a little bit warmer over the next day or so, that ice would basically start to melt out. That piece would probably fall to the ground, and as soon as whatever the ice plug that's left inside this drum drip melts out, then the valve would trip. Here's kind of an example of different broken drum drips in the field. Starting on the left-hand side, basically the valve, the pipe piece just fractured, probably along its seam because of the fact that the water expanded. The second to the left is a good picture of what would happen is if the drum drip was almost completely full, as a 2-inch column of ice would rise. As it got up to the reducer, it's just going to continue moving upwards to the point where it will not be compressed to the shape of the reducer, and therefore just cracked out the reducer itself. The middle picture is just an example of something that's probably been broken multiple times and then just repaired with whatever pieces and parts happened to be close at hand. The one to the middle right is kind of an example of what we see a lot of times in the field is, again, because the reducers have been replaced, you can see that this thing has probably been broken out at least once or twice. And then the picture on the far right is just a fractured valve body, similar to the picture I had shown you earlier. The problem you have is that the amount of condensation that might accumulate in an auxiliary drain is impacted by too many variables to be able to determine a specific frequency for checking the drains to prevent these types of problems. As an example, the required rate of air leakage for a new system being put into service is no more than 1.5 psi over a 24-hour period. But the acceptable rate for an existing system is 3 psi over a 2-hour period, or roughly 36 psi over the same 24-hour period, which is about a 2,000% increase. Now, air leaks out of a system a lot easier, and much of it depends on the type of system you have and the location it's at, and a number of other factors. Now, I mean, that sounds like an incredible difference, but the commercial compressors that are used to keep the air in the system are designed to deal with that 36 psi over a 24-hour period very easily. So that's not the problem. But the problem is the more frequently that the compressor is kicking on, the more condensation that will be made in the system. Now, the things that impact how much air will be needed in the system have to do with the system's age, the type of building that the system is located in. As an example, a freezer warehouse inside of a regular warehouse is a very stable structure. It doesn't move around a lot. The temperature in that facility is always kept below freezing. Those systems don't tend to develop air leakage as frequently as a system that's put into a parking garage would. A parking garage, you've got constant movement as the cars move up and down the different levels of the parking garage. Expansion and contraction that's caused by summer and winter. You know, as in the summer, as the concrete in a parking garage heats up, this building expands. Those tend to move things around a little bit, which tend to open up a system and increase its leak rate. The moisture content of the ambient air in areas, say, down along the mid-Atlantic coast, Washington, Baltimore, Philadelphia, New York, down into Virginia, those areas tend to accumulate more moisture in their dry systems because of the fact that the ambient air has a much higher dew point to it. So therefore, when the compressors are sucking air in to compress it down to fill up the system, you result in a higher moisture content within those systems. You get into an area like Denver, or up where the air is significantly drier, it's maybe not as big of an issue. The hot and cold cycles. Obviously, the more that a system is exposed to hot and cold cycling, the more likely it is that you will potentially have problems with the drum drips. In the winter up in Minneapolis, things will potentially freeze up and they may stay frozen for long periods of time. You get into markets like the panhandle of Texas, it's not uncommon to get 3 days of freezing weather followed by 3 days of 60, followed by another 3 days of freezing weather. So these are all different factors which influence how much water might accumulate in a system. This is kind of our group of products that are designed to deal with. So, I mean, although NFPA only had that one diagram, based on feedback from people like yourselves, people who install systems, we started to ask people what some of the different problems that they were encountering were, and we tried to come up with solutions for some of those problems. This is the basic drum drip that we talked about earlier. One of the biggest and silliest problems people mentioned was that the people who did it last year aren't still with us this year, or the process of doing it didn't get translated well, and as a result, they inadvertently tripped the drain, things of that nature. Or if you remember those pictures of the ones that were just painted white, nobody knew what it was, and therefore they didn't want to touch it. Plus, it had no handle, so nobody was able to know what to do with it. So we actually just put signage right on the unit identifying what it was, And then we also put the instructions on there as what to do with it. And this was designed to just make it easier, say, for the person who might be responsible to do this the first part of November and hasn't touched this thing since March of the previous year, and sort of remind them the process. Also, it's a requirement of code that these things all have signs on them, and typically it's a hanging metal sign that's hung off the pipe. A lot of times it's not there. A lot of times it's lying face down on the floor of the garage to get sucked up by the tenant machine. So we thought literally putting the sign on the unit would be a better way to do that. This is a small little device that's designed to chirp and alert you to the fact that there is moisture in the drum drip. Just gives you an audible alarm. One of the people in our office here joked about the fact that when they go home at night, everything in the house chirps at them when it wants its attention. The washing machine, the dishwasher, the dryer, the kids, everything. So why couldn't we make something similar for a drum drip? These would just be placed in the bottom location of a drum drip. As I said, we can get a drum drip to break out with less than 2 ounces of water. So any amount of water in a drum drip can present a problem. Here's an example showing that installed onto an older drum drip that was already existing in the field. It can be easily retrofitted on. As the block on the right-hand side says, this thing can be powered either by a battery, 12 volt, 24 volt, or even 110 volt. And it would just chirp to let you know. It's like sort of like the battery detection alarm in a smoke detector. In other words, the battery is wearing out, time to change the battery. Or you can get it actually on a drum drip already pre-assembled. Now, this whole assembly could also be flipped around, and you could have this thing at the top, but you would only want to do that if this drum drip was in a conditioned environment. Where we've seen that done is in a lot of nursing care facilities. They have dry systems up in the attic of the facility, but then they bring the drum drip or the auxiliary drain down into the first occupied level of the facility, in which case there we're more concerned with the drum drip filling and the water going up into the attic where it would be at risk of freezing. But if this is in a conditioned environment, then the alarm could certainly be put in the top position. This was an invention we came up with. We actually have a patent on this. This was designed to keep people from being able to do the process wrong. This is based on feedback we got from the home center industry, in that they said, which is typically the garden area, that they had problems in the summer with some of their summer personnel actually thinking that the valve on the sprinkler system was a great place to get water to water the plants in the garden center. And unfortunately, they would end up tripping the systems. So this is designed so that you have to close the valve in the top before you can open the valve at the bottom, and then you can slide it up. This also creates a way that it's easy to lock it out to avoid some of the bizarre lockout features we saw in those pictures earlier. And this can be gotten with or without the alarm. And then we move to a model 5400, which is we create a conditioned environment for the drum drip to live in. So this is a heated box. It is heavily insulated. It now has a float switch in it. Since the drum drip is being safely kept above freezing, we can allow water to accumulate in this to the point of being full, and then it would alert you to the fact that it needs to be emptied, which just makes servicing it a lot more worthwhile, because you're only servicing it when it really actually needs to be serviced, rather than guessing if it needs to be done. And then we make that in a couple different versions. And basically that's kind of it. So now I'll open it up to questions. And here's one question. What is the life expectancy of a dry system? Well, there was a study done a couple of years ago by a company called VDS, which is like the European equivalent of UL and FM. And they did some long-term extensive studies, and they discovered that within about a 12.5-year period, 73% of dry systems would be considered compromised, typically by corrosion. Most dry systems are built using galvanized pipe. Galvanized pipe is designed to basically keep pipe from corroding from the outside in. But a lot of times, dry systems have a problem corroding from the inside out. What happens is you have a situation where your galvanic coating may have gotten, might either be thin or missing or chipped off or something like that inside the pipe. And as a result, corrosion will really bore into that space. Also, when they cut the threads into the pipe or cut a groove into the pipe, a lot of times they will end up literally cutting off the galvanic coating, and then that creates a point where the pipe will be vulnerable. One of the best things to do is to make sure that the pipe is pitched correctly so that you get as much water out of it as possible. Here's some other questions. Can the local alarm chirp be connected to the fire alarm in supervisory mode? Yes. Both the small device that is located at the bottom of a drum drip that is installed in an unconditioned environment has the ability to be wired back to a fire control panel or a business or a building management information management system. So yes, they can connect back. Next question. How often would you need to test the drain in regions like the Midwest, Eastern Seaboard, Middle South, like Texas? That kind of goes back to that frequency. There's so many variables that you can't guarantee somebody that you say, if you test this or if you empty these things once a week, you're not going to have any problems. And those of you who are in buildings that have, or a structure that has multiple drum drips may find that one drum drip tends to collect most of the moisture, and therefore the other ones are kind of ancillary. So that one is constantly full, but the other ones may not, and therefore sometimes they get forgotten and water will accumulate and those will cause problems. Again, it has to do with specific conditions, the type of building you are, where you're at, the humidity in the air, the type of compressors that you're using, so on and so forth. And that's kind of the big variable, which is why these things tend to be somewhat problematic. Is this deck available? Yes. They'll make this presentation available to anyone that is interested. I think, how often should drum drips be checked? As I said, that kind of varies building to building. And yes, we can get it. How often? Is there an automatic feature that will empty the drum drip chambers when moisture is detected? Actually, yes. We make a version of that automated, the 5400, an automated version of that called the 5500. It uses motorized ball valves, and it can be set up to work in a number of different ways. It can be activated by a building automation system. It can be designed to literally activate itself in that it would figure out that it's full, it would close the valve in the top position, it would open the valve in the bottom position, and then it would drain. What you just have to be aware of is code currently requires that the bottom of a drum drip have a cap or a plug in the pipe that's coming out of it. And obviously, they want to make sure that you're not going to be dumping water all over the ground in an environment that is subject to freezing, because it would potentially cause a slip and fall hazard. So if you're going to use an automated version of a product like that, you need to do it in such a way that you've made accommodations for the water to be drained safely. That is sometimes difficult if you're retrofitting something into an existing building, because that wasn't taken into consideration at the time. I mean, ideally, a building would be set up with one drum drip that back drains into an environment that's heated. In 30 years, I've never seen one that works quite out that way. would you recommend a dryer moisture collector on an air compressor? This is going to be based on a lot of different things, like the environment that the system is going to be in, if it's a particularly wet environment versus a drier environment. As I said, a freezer warehouse tends to be a very dry environment. Therefore, it's probably not necessary. Panhandle of Texas, East Coast, along the coast, or in areas that are prone to a lot more moisture, a dryer is certainly a consideration. There's a company called General Air that makes compressors specifically for dry systems. They also make compressors that have dryers on them, and they could certainly provide you a whole lot more information and recommendations with regards to it. But it is certainly something that should be considered if you live in an environment, or if your system lives in an environment that has a lot of moisture in it. Well, Nelson, you're welcome. Next question. Does the 5400 require a dedicated and supervised power source? Actually, no, none of these would require a dedicated supervised power source. The 5400 does require 110 power, but it can be simply plugged in. It only draws about 3 amps, so you could easily put as many as 5 of them onto a single 20 amp breaker. And I would certainly make sure it was put onto a circuit that wasn't, inadvertently hooked to a switch that could be easily turned off. But there is no requirement for them to be specifically attached to a supervised electrical circuit. We ran a little bit long here because of the fact that we had a little bit of an issue getting started. If there's additional questions, we will certainly forward answers to you accordingly. And other than that, I appreciate everyone's attention, and thank you.